Hello and welcome to Forrester High School Maths Department's National 5 Maths Support Materials. My name is Mr. McDonald and I'll be talking you through your topic today. Today's learning intentions are to be able to change the subject of an equation and to be able to manipulate equations to find other variables besides the subject variable. This is exactly the same as the last video that you would have watched, except for we're going to take this subject a little bit further today. Okay, so just to remind you from last time, changing the subject is the name that we use for rearranging an equation to change the focus of that equation. So in this case, we've got the volume of a cuboid formula here. The subject is V because that is the focus of this equation, and the substantiative terms, those are the things that you need to know in order to calculate V. If we change the subject, we can change that equation to say L equals, B equals, or H equals, and have the other terms as substantiative terms instead. That's what we do when we change the subject. So before we start some examples for today, I just want to remind you as well that when you are rearranging an equation, when you're changing the subject, it's really important to know your inverse operations or your opposite operations. So last video we looked at add and subtract being opposites, multiply and divide being opposites, and you're quite used to, when you're solving equations, doing those things on both sides to either counteract an add or a subtract or a multiply or a divide. That's nice and easy. In this video, we're going to look at a few other things that are a little bit more complex, so I just want to introduce you to a few other opposites. Squared, which means multiply something by itself, has an opposite of square root. Cubed has an opposite of cubed root. That's the same as the square root, but with a little 3 in the top left corner. And then sine, cos, and tan are trig functions. They have inverse operations as well. In fact, they're called inverse sine, inverse tan, and inverse cos. Okay, so just bear those things in mind. You can always come back to this page and pause if you need to, if you want a reminding of any inverse operations. But we're going to look at all these things today. So here's a quick example. We want to change the subject of this equation y equals 5 bracket p plus 2 all squared to p. So we want this rearranged so that p is equal to something. So what's happening to p in this diagram? Well, first of all, in the brackets, it's having 2 added onto it. So the first thing that happens to p is 2 is added onto it. The second thing that happens is the orders of operations. So it is being squared. I'm going to put a little up arrow and then a 2 to show that it is being squared. And then the final thing that's happening to it at the start of this bracket here, it is being multiplied by 5. And those 3 operations there in the circles follow BODMAS because the first one is in brackets, the second one is an order of operations or a power of, and then the third one is a multiply. Okay, so we've gone B, O, and M during this equation. And that gives you the answer of 5 bracket P plus 2 squared. So we need to undo that. Well, what we're going to do first is we're going to rewrite this equation, but with the P, the variable that we want to make the subject, on the left-hand side. So 5 bracket P plus 2 squared. Everything on that side of the equation comes over to the left-hand side, and everything on the left-hand side of the equation becomes the new right-hand side. So in that case, it's just y. Okay, so the first thing we need to undo in terms of changing the subject of this equation is a multiply by 5. So we're going to use our inverse operation of multiply, which is divide. We're going to divide the whole left-hand side of the equation by 5, and we're going to divide the whole right-hand side of the equation by 5. That gives us an answer of p plus 2 in brackets squared is equal to y divided by 5. The next thing we have to undo is we need to undo this squared that's outside the bracket. Okay, so to undo a square, I'm going to square root everything on the left-hand side, and I'm going to square root everything on the right-hand side. That gives me p plus 2, but no squared and no brackets, equals the square root of y over 5. And then the last little thing, to undo a plus 2, all we need to do is subtract 2 from both sides. This is the easiest part of the equation when you get to this point. And our final answer for p equals, our subject has been changed because we've got p on its own, isolated on the left-hand side. Our final answer is y divided by 5 in a square root bracket, and then take away 2 at the end. Just make sure that that take away 2 is not inside your square root bracket because it was on the left-hand side of the equation when you square rooted. And that's our final answer. Okay, so here we have another example. W is equal to the square root of k plus on 4, all divided by 3. Remember, if you have a fraction with more than one thing on the top of it or the bottom of it, that it's like there is a bracket around those two things. So they're kept on the top of the fraction by that bracket. And things in brackets have to follow the order of BODMAS as well. So the first thing that's happening to k here is it's being square rooted, because that is a power of or an order of. It's part of the O of BODMAS. And then the plus 4 happens. That's part of the A, the addition of BODMAS. And then outside the brackets, we've got the divide by 3 as well. That's the final thing that's happening here. And that is how you get the square root of k plus 4 all divided by 3. Again, difficult to fit in that box, but you get the idea. Okay, so the first thing that we have to undo here is a divide by 3. I'm getting ahead of myself a wee bit because what we need to do is we need to rewrite this so that the k, the thing that we want to change the subject to, is on the left-hand side of the equation, and the w is on the right-hand side of the equation. Okay, so next step, we need to get rid of the divide by 3. We are going to multiply by 3 on both sides of this equation in order to get rid of that. I've just realized that my square root sign is just a little bit too long as well. That should only be over the k and not the plus 4. Okay, so when I multiply both sides by 3, I get the square root of k plus on 4 is equal to 3 times w, which is 3w. The next thing I have to undo is the plus on 4. So I'm going to take away 4 from this side of the equation and take away 4 from this side of the equation. I'm left with just square root k is equal to 3w take away 4. And then the last thing I need to undo is the square root. Remember, squared and square root are opposites of one another. So I need to raise this to the power of 2 and raise this to the power of 2, square each side. And I get on its own k is equal to 3w minus 4. I'm going to put that all in a bracket because I have to square it all. Again, if you wanted to write that in a slightly different way, you could expand your two sets of brackets using FOIL, but I'm happy with just k is equal to 3w minus 4 all squared. Okay, we've got one last example here. We've got y is equal to 5 sine a divided by 3 plus on 1. So again, we need to figure out what is happening in what order. The first thing that's happening is an operation. It is a sine of A is being taken. And then it is being multiplied by 5. That's being divided by 3. And then it's having 1 added onto it. It's important to note here actually that I've put the multiply by 5 in front of the divide by 3, but technically following BODMAS it could be the other way around as well. Remember, multiplying and dividing are interchangeable. Okay, so I can put them that way around if I want, or I can put them around this way if I want. Okay. Alright, so let's rewrite our equation so that our subject variable, our A, is on the left-hand side. 5 sine A divided by 3 plus on 1 is equal to y. Again, if I want to undo a plus on 1, I use the inverse. I take away 1 from here, and I'm going to take away 1 from the other side of the equal sign as well. That gives me 5 sine A divided by 3 is equal to y. Take away 1. The next thing I want to undo is the divide by 3. I'm going to times by 3 on both sides because that's the inverse operation. So multiply by 3 here, multiply by 3 here. And I get that 5 sine A on its own is equal to 3 lots of y minus 1. Again, if you wanted to multiply this bracket instead of having a bracket, that's absolutely fine. You could have 3y take away 3. The next step, undo a times by 5. You do that by dividing by 5 on both sides of your equation. So sine A is equal to 3 lots of y minus 1 divided by 5. And then the last part of this, to undo a sign, which you might not be as familiar with, but it was in National 4, the opposite of sign is the inverse of sign. So we're going to take sine to the minus 1 of both sides of this equation, and we get that A is equal to sine to the minus 1 of 3 y minus 1 divided by 5. Again, if you don't want that double bracket in there, you can have 3y minus 3 on the top of that fraction, and that means you've not got a bracket sitting inside another bracket. But again, that is your final solution, just following those steps backwards towards your subject variable. Okay, so I get what you're probably thinking. That's all well and good, Mr. McDonald, but how do I use this in a real life context? Okay, so what I've got here is I've got a microbrewery still. It holds 10,000 centimeters cubed, or 10,000 milliliters of liquid. It's 75 centimeters long. What is the radius of the still? Okay, so we should know from our National 4 that the volume of a cylinder is equal to pi r squared times the height. So pi times radius squared times height, and that gives you the volume. But we're not asked for the volume, we're asked for the radius. And radius is part of that equation that we've got up there, but it's not the subject. So what I can do is I can change the subject of this equation. If I think about radius, what's happening to it? Well, first of all, it's being squared. Second of all, it's being multiplied by pi, which is just a number, and h, which is just another number. And that gives you pi r squared h. Okay, so those are the things that we have to undo. I'm going to rewrite my equation with radius on the left-hand side. I'm going to put pi first anyway though. Pi r squared h, you could write that r squared pi h if you wanted to, equals v. The first thing I have to undo is the multiply by pi h. So on both sides of this equation, I'm going to divide by pi h. Remember, pi is just a number, so don't worry about taking it away, adding it on, dividing by it. You can do all those things with a calculator. So when I divide by pi h, I get that r squared on its own is equal to the volume divided by pi times h. If I want to find r on its own, I need to undo the squared. So I'm going to square root on both sides. And I get that r is equal to the square root of v divided by pi h. That's me got the radius of that still. Except for I don't have the radius of that still on the board. I've got the radius of any cylindrical still. Right, now all I need to do is put in the specific information for the still that I have on the board here. So taking a different color, I'm going to use purple. My radius for this particular still is going to be the square root of the volume, which is 10,000, divided by pi times h. That's pi times, in this case, 75, because the still is 75 centimeters tall. If I put that all into a calculator, I get the final answer of 6.51 centimeters. So it's quite a small still, 75 centimeters tall, about 13 centimeters rather, along the top in diameter, and its radius is 6.51 centimeters. All right, the way I did that was I rearranged the equation and then I put in the specific information for this still. All right, it works the other way around too. If you put in the information first and then rearrange your equation, that works absolutely fine as well. But you should always get to the point where r is equal to 6.51 centimeters. All right, that's the end of your video. Thanks very much for watching. Remember, for your assignment, you can ask any questions you like on Show My Homework and through email. Make sure that you're not being shy about asking questions because I know this is a difficult topic. Remember, you can start late, start over, be unsure, and try and fail, but make sure in the end that you're pushing forward and being successful. Remember to upload your pictures of your work to Teams so I can mark it and give you some detailed feedback. And very well done for completing this video. Good job.